Hi there, curious minds. I'm Sol the Sloth, and I love all things electrical engineering. It's fascinating how tiny electrons can power up our world. From the lights in your house to your video games, it's all thanks to the magic of electricity. At Celtic Engineering Solutions, we're all about understanding how electricity works. And today, I'm going to teach you about two super important concepts: resistance and impedance. Don't worry, they sound complicated, but they're actually quite simple and fun to learn. Are you ready? Let's dive in. Imagine you're riding your bike on a flat road. Easy peasy, right? Now imagine riding uphill. It gets harder, doesn't it? That's because of resistance. In electrical circuits, resistance is like that uphill battle. It's the opposition to the flow of electricity. The higher the resistance, the harder it is for the electricity to flow. We measure resistance in ohms, omega. See, it's already getting easier. Now for a little bit of math magic. We use this special formula, R equals V over I. R is resistance, V is voltage, the electrical push, and I is current, the flow of electricity. This formula tells us how much resistance there is based on the voltage and current. Cool, right? Now let's talk about impedance. Imagine you're flying a kite on a windy day. The wind can make it harder to control the kite, right? That's because the wind is creating impedance. Impedance is like resistance, but it's a bit more complex. It's the total opposition to the flow of alternating current, AC, which is the type of electricity in our homes. Just like the wind affecting the kite, impedance can change depending on the frequency of the AC. We measure impedance in ohms too, but its formula is a bit fancier. Z equals R plus JX. Z is impedance, R is resistance. Remember our uphill bike ride. And JX represents reactance, which is the opposition to the flow due to things like capacitors and inductors. Don't worry too much about those right now. Just know that they add to the overall impedance. Section 4. Resistance and impedance working together. So, how do resistance and impedance work together? Think of it like this. Resistance is like the friction of the road when you're biking, and impedance is like the wind pushing against you. Both make it harder to pedal, but in slightly different ways. In electrical circuits, resistance and impedance work together to control the flow of electricity. We need just the right amount of each to make sure everything works properly. Too much resistance or impedance, and our devices won't get enough power. Too little, and we risk damaging them. It's all about finding the right balance.
Sol's super summary of circuits. So there you have it. We've learned that resistance is like riding a bike uphill, and impedance is like the wind affecting our kite. They both make it harder for electricity to flow, but in slightly different ways. Remember, resistance R is the opposition to the flow of electricity in general. Impedance Z is the total opposition to the flow of AC electricity. We need both resistance and impedance to control the flow of electricity in our circuits.
Keep exploring with me. Sol, I hope you had fun learning about resistance and impedance with me today. Keep those curious minds exploring, and remember, the world of electrical engineering is full of amazing discoveries. Stay tuned for more fun lessons with me. Sol the Sloth. Sign up to ask me. Sol the Sloth Scientist, from Celtic Engineering Solutions. Anything about electrical engineering.